Hi, welcome back. In this module, we are going to be talking about hypothesis testing, leading into statistical significance and what that means and why it's important. A hypothesis is basically a prediction that some sort of relationship exists between the variables that you're trying to test. So that you, for example, you may predict that there will be a difference between men and women on levels of self-esteem, for example, just as an example of a hypothesis. Now, there, generally speaking, in academia, you should have a reason backed up by theory for your predictions. So you should build on past research. And in your specific cases, your level of rigor needed for to establish a hypothesis may be significantly less. But it's still a good idea to have some sort of idea of why you're asking that question, what makes you think you can make that prediction. Because if you have no backing for your prediction, then your relationship may end up being spurious and not really a real life representation of a relationship that exists, even if your test proves that the relationship is statistically significant based on your data set. So your hypothesis should be backed by theory or some sort of, you know, general common understanding of a relationship that exists. Now, there are two different types of hypotheses. There's a one-tailed and a two-tailed hypothesis. A in the example of a group difference, so that men and women have different levels of self-esteem, that is a two-tailed hypothesis. It just predicts that there is a difference on this variable between the two groups. In the case of a one-tailed hypothesis, I would predict, for example, that men have higher levels of self-esteem than women. So there's a direction there in your data. You expect that a group will be higher or lower than another group. So that's important to consider, especially when you get into the levels of statistical significance, and we'll talk about that in just a few moments. So when you start off, you make your hypothesis that you come up with is going to be predicting something. So you predict a difference, just like the men and women self-esteem hypotheses that I used an example a minute ago. Uh, However, all of your tests do not test that hypothesis. This may seem somewhat counterintuitive, but it actually is a good thing. So you are testing the null hypothesis, and you want to provide evidence that you can reject the null hypothesis. So in our example, where men and women have different levels of self-esteem, the null hypothesis is that men and women have no difference on their levels of self-esteem. So that is your null hypothesis. And based on our data and the tests that we run, we seek to reject the null hypothesis. This will provide some sort of evidence that supports all our alternative hypothesis over the null. So, this is kind of a deep philosophical issue, and we're going to discuss this in the discussion question below. So please answer why you think it is that science seeks to reject the null hypothesis rather than accept an alternative hypothesis. Why is that a good thing? Why is that why the system works? So and think about that and put your comment below based on that issue. So if our data is able to reject the null hypothesis, then we will have statistical significance of our difference or our correlation or something along those lines. So this is where we can say that our test is successful, that it won, and our data lined up with our hypothesis, and everything worked out. So this is what is also your p-value in any sort of academic paper. It's your level of statistical significance. And the general standard is 0.05. So you'll have a p-value lesser than 0.05 to show that a relationship exists on this data. that it is statistically significant. Now that 0.05 level actually refers to the amount of data that is under the normal bell curve. So this, stick with me for a minute, and we'll look at our bell curve back again. So here is the mean, this line down the middle in the bell curve. So in the case of a group difference, so that men and women have different levels of self-esteem, to show that that is statistically significant, this bell curve would represent the measures of all levels of self-esteem for all of the participants in our study. If this relationship was statistically significant, so for example, if men had higher levels of self-esteem than women, then all or the majority of the data points that were men would lie on one end of the spectrum of the bell curve, all the way over here on the high end. So if we were able to do that, if there was that difference, then all of our data points would lie under the bell curve at this point. And that's what we're testing in the case of a group difference, to find out of all of our data, we want to see if our single group that we expect the difference, their data, their points on this variable, on this measure that we have, lie all the way at this end of the spectrum compared to the rest. And that's what we mean by statistical significance. Now, in general terms, this means that you are 95% positive that the relationship that you have perceived by your data is not occurring by chance. So having all of your data on one end of that bell curve in that spectrum shows that you're 95% positive that you've discovered something here, that there is a difference between these two groups based on this variable. And we get into this type of issue like, excuse me, we'll take a little bit of a step back. Let me rephrase. We'll go back to the importance of having one and two-tailed tests when it gets to this level of statistical significance. So, in a two-tailed test where you just predict a difference, it is actually a higher standard of rigor on that difference, because that 0.05% of the bell curve that is our statistically significant regions lie on both ends of the bell curve. So if, for example, all of the men were higher in self-esteem, then they would all have to be at the 0.025 level, all in this critical region, the 0.025% of the bell curve. They would all have to be in there. There would have to be a majority in there for it to be a statistically significant relationship. If you were predicting that there was solely a difference between men and women on self-esteem. However, if you predicted that men would have higher levels of self-esteem than women, then this side of the bell curve is factored out of the equation, and the 0.05% all lies on this end. So the critical regions is actually larger in the case of a one-tailed test than a two-tailed hypothesis test. So if you can, you want to have a one-tailed test, but that needs to be backed up by theory, or there needs to be a reason for that sort of prediction, because you're more likely to get significance from your data. So that's the quick down and dirty on hypothesis testing and statistical significance. If you have any questions, please ask them below, and remember our discussion question and answer that as well if you have anything to contribute. And I will see you in the next module.